So what I want you to do, like I just have 2 slides to do. This one, which I think it's the very last one you had shared with you in that presentation. Only want you to do that left-hand problem first, and then I want to show you the last U-sub method we have to learn, and then we'll go back and do that one with the V-sub. I just want to remind yourselves of the U-sub process, and then basically you'll have time in class today to work on homework and all that. So just do that first one for me, and then we will get started. Remember when you're looking for a U substitution, you want to make sure you choose a correct U. Like I will say for this problem, the wrong U, which is a very common U that people want to choose, is they'll say U is equal to 3t, because they do see that 3t is inside of a function, and like that works, like you'll get U prime is equal to 3. That's still like a constant multiple in the problem. But when you go to rewrite it, you have sine squared of U, cosine of U, and then we know that in this case it's dt. dt would be du over U prime. Like there's nothing wrong about that. Like that's still correct U substitution, but what's wrong with that integral that you still have to find?
Sine.
It's like a sine squared times cosine. Like we don't have a rule that lets us integrate that. So that would not be the U that we want to choose. What would be a smarter choice in your U? What else is inside of something? What's inside the square?
The sine.
Sine of 3t. So that's what I would actually choose to be the U. So I'm going to let you finish that one. Let U be this part, just the sine of 3t. Find U prime and take it from there. So this is kind of where that practice kind of helps. We just kind of start seeing problems and seeing what's going to be the best U to choose and how is that U going to help you actually simplify the problems.
So how would you sine 3t?
I'm just trying something because I see that this is like sine squared. So like what's inside of the squared, sine of 3t is technically inside of it. Do make sure, of course, when you're doing that, like you still follow all of your derivative rules. So if you're saying that U is equal to the sine of 3t, U prime, don't forget the chain rule, that becomes the cosine of 3t times 3. And then we can use that to rewrite the problem. So we have the integral, it was the sine of 3t squared, now it's just U squared. That cosine of 3t is still there. dt would be du over U prime. And we can see that this is going to work a lot nicer because those cosines cancel. And we have a much more simpler integral to deal with. That is just 1/3 is in the denominator, or excuse me, 3 is in the denominator, 1/3 on the outside, U squared left over du. So like choosing the correct U for kind of comparing those, the one I crossed off and the one that we're doing it. Definitely when we chose a bigger U, we had like more stuff canceling, and it became an antiderivative we don't know to an antiderivative that we do know. Yes, sir. No, you don't. I just like moving my coefficients on the outside just to get them out of the way, but like you could leave like over 3 on the inside. But then that just becomes another easy one to solve. So I have the coefficient of 1/3. We're going to add 1 to the exponent, divide by the new exponent, don't forget your plus c, and then go back and plug everything in. So you have a coefficient of 1/9. Your U was the sine of 3t, and now it's cubed plus c. And of course, you can always check your answer by just taking the derivative of it. Pretty easy to check to see how that 1/9 would cancel out. Like first, that 3 would come down in the power rule, so it becomes like 1/3. And then when you do the chain rule, times a 3 at the end would cancel out that other 3 remaining. But of course, you can always check your answer by taking the derivative. So when it comes to U sub, like I have a classwork activity we're going to do today to help us practice and decide the best U. I think it's often difficult to determine a U, especially when you have like a product of trig, and just kind of takes practice and seeing like, okay, when it looks like this is a good U. When it looks like that, this might be a better U. The one type of U substitution problem, though, that I do want to do that I did not get to yesterday would be something like this. So I have like what if here, because I have the integral of this x times the square root of 1 minus x dx. And this is going to be like the one type of U sub where things just like don't work out nicely, but we can kind of force it to work out like we want it to. So I just tell you to go ahead and do this one. Like first off, let's make sure we can't just integrate each part of that. Like there is no product rule. You can't just integrate each factor. We do need to do U sub to find a way to rewrite it. What would you let your U be equal to if you're looking at this problem? 1 minus x. So like 1 minus x is definitely inside of something. So we can let U be that 1 minus x. So U prime is going to be -1. Plugging all of that in, so we have the integral of x. This is now the square root of U. dx we know is du over U prime. What do you notice is wrong or kind of just making the issue in this problem? That x doesn't cancel. But there is an easy way to get rid of this x. So right now this x is kind of stuck in there. We want this, it's called U substitution because we want everything to be in terms of U. Can I figure out an expression for x that is in terms of U?
Yes.
Yes, we can. We just wrote this equation up here. We said U was equal to 1 minus x. Well, that is an equation. We know kind of like any equation we move around is also true. So if U is equal to 1 minus x, what would x have to be equal to? Solve for x. 1 minus U. And then you can just do like another substitution. So like if I actually rewrite this one, I'm going to move that negative on the outside just because I don't like dealing with it. X is 1 minus U. The square root of x, I'm going to write it as u to the 1/2, and then du. Now that is an integral that we can do because everything is in terms of u. But before we just integrate it, we still have a product. How do we get rid of the product though now? Just distribute it across. So now we can distribute this across. So I have the integral, again I had that negative from the u prime over here. 1 times u to the 1/2 is just u to the 1/2 minus u to the first times u to the 1/2 is u to the 3/2. And now I'm integrating that with respect to u still. So go ahead and finish that problem. These often are ones that like the derivative, the original function, the antiderivative looks very, very different from the derivative. But you remember that oftentimes when we found derivatives, we often had to do a lot of simplifying. So like this is kind of like the way to undo all of that simplifying. One half plus 1 is 3/2. New coefficient would be 2/3 minus 3/2 plus 1 is 5/2. New coefficient would be 2/5. I kind of have that negative hanging on the outside, going back and plugging in your u. Can definitely leave your answer like this. If this was a multiple choice question on the AP exam, that negative would be distributed across, and this would be the original function or the antiderivative. Again, looks like that shouldn't be the derivative when you simplify it, give you what you originally had in that problem. Where this is coming from, if you kind of remember those problems you did, like you found the derivative, you had to do like, this would be like the power rule coming across. You end up having like a GCF, that fancy factoring, and when you factor things out, it's going to give you that simplified answer. That's the only type of U-sub problem where it just doesn't work out nicely, but you can still find the expression in terms of U because of this original equation you write of what you're setting U equal to. Questions on that process? Last notes example then, go ahead and try that last problem we didn't get to on that same page. So this is in V's, sorry if you don't like using things other than X. Sometimes when you have a fraction that dv is just written in the numerator, this is the same thing as just saying v over the square root of 2v minus 1 with respect to v. But this will be an example where when you start to integrate it, all your variables don't cancel out, but you just need to rewrite it in terms of u, and then you can do it here. Not really any crazy algebra, but typically we'll have like fractional exponents and all that. try that, and I'll tell you about the classwork assignment. And when you finish there's my work, I'll explain it once more people had a chance to finish it. I could simplify my answer by distributing a coefficient across. Again, I like kind of just leaving them out in the front so I don't have to worry about them getting in the way of my math. So looking at this one, I let u be again what was inside that square root sign. I let u be 2v minus 1, u prime would be 2. Automatically, I know there's going to be an issue because with u prime being 2, it's not going to cancel out that v that was already in the integrand. So solving for v, I got that v was equal to u plus 1 all over 2. You might have written it differently, like if you said 1/2 of u plus 1/2 was v, you would also still eventually get the same answer I did. So then doing my u substitution, the original problem, I rewrote it. I brought that negative 1/2 up as the exponent. So I had the v times the u to the negative 1/2 du over u prime. Again, you don't have to, but I like pulling all the coefficients out in the very front so I don't have to worry about them. So I had like 2 number 2's in the denominator, so 1/4 on the very outside. And then we had to distribute that u to the negative 1/2 across. And then just did the power rule and did the antiderivative. Do notice how I wrote my answer. So like that 1/4 I left as a coefficient. In brackets, I just put the antiderivative, and I had like the plus c kind of hanging out on the very, very end of that. But that's kind of the weird u sub method where everything doesn't cancel. Definitely will have one where you have to do that on your test on Friday, just because it does show up on the AP exam.
Why doesn't the C get included when the one with distribution?
So, like you could include it. I leave it on the outside because again, the question for this at home was why was the C on the outside of the brackets? And when I think about it, it's like the antiderivative when you do an indefinite integral, it's the antiderivative plus some constant. And the issue is we kind of run into like this gray area. Like if I put this plus c on the inside, it would be like a different constant than with the plus c on the outside. You would end up having like 1/4 times that constant. So like, is it completely wrong? No. But when we start doing next semester in the unit with differential equations, we will have to be more careful where we put the plus c, because it can affect the final answer when we go back to solve for it. I just do that kind of by habit, and it makes the math second semester or some stuff we do easier for you. But I wouldn't mark it wrong if you left it on the inside. So what I want you doing now, like I know you have the USUP homework. I had this handout. I wrote it last year, and it seemed to help. So I shared it with you in OneNote for you to kind of pull it up, but it's under 41-more USUP. It should be probably the last thing I shared with you. Not going to ask you to do all of it. What I am going to ask you to do right now is just questions 1 through 6. And what I did is I basically wrote 6 integrals that all look almost the same, like they all involve for the most part secant, tangent, some just secant, and like changing up the exponents. But they're all done kind of differently. Like some actually are U sub, some are not U sub. For some of them, the U is just a 2x. For some of them, the U is like an entire trig. So I think this activity will help you kind of see and have that practice of choosing the best U. I'm not going to do it up at the board, but the answer key to it, if you scroll down, is at the very bottom, except for me and making typos in 3 and 4. I wrote x instead of 2x. Also made that mistake last year and just never fixed it. But you'll catch that mistake when you look at it. The second page, I'm not going to like require it to you to do it, but this is just some extra practice if you want it. Part 2 has you ones where you change the integral, the numbers on the integral sign to be in terms of U, just to practice that. And then I also have 2 questions that are commonly missed because people do them incorrectly. So if you want to do them as a review for your tests and have time, like I definitely recommend them. The key's there. But what I do want you to do right now is just these 6 questions. Some of you will go through them pretty quickly. Some of them might take a little bit longer. Again, the key is on the bottom of the page. But what I want you to pay attention to is like when you see a problem, getting used to being able to choose, like choosing the U correctly so that it becomes an antiderivative that you can find. And I like these. I am biased because I made it, but I like these because some of them, when you change it to U sub, it becomes like a power rule. Some of them, when you do U sub, it still remains a trig rule. So kind of being able to distinguish what it looks like when you do U sub is important. And then when you finish that, then you can just use the rest of class to work on like homework. I shared with you the briefcase binder already, quiz corrections and whatnot. Basically tomorrow and Thursday we're just reviewing with your test on Friday. And I mentioned it, I feel like I've mentioned it to people in passing. I just want to kind of say it to everyone while I have the people at home still here. So how I'm going to finalize your grades this semester. Fulton County is requiring 80% of the summative assessments to be complete. So at Roswell, every teacher has 12 summative assessments. So what I am going to do, and just to kind of just like as an incentive, we'll have 12 assessments by the end of the semester. I am going to go in and I'm not going to drop the lowest 2 because I can't technically do that. What I am going to do is I'm going to go to your lowest quiz and to your lowest test and just change those to an incomplete and just pretend like you never took them. There won't be a final for this class, like we just don't have time. We have 6 units, and with a quiz and a test in each unit, like 6 times 2 is 12 already. For the very last test, it will be given during finals, but it will just be a regular test, and it's going to be your Unit 6 test, which could be the one that you take an incomplete on, but it still is going to cover topics that you definitely need to know next semester moving forward. That's just kind of how I'm going to do grades. There won't be a final just because there just won't be time. But I will go back and before I post grades, look for your lowest quiz grade, change it to an I like you never took it, and then look for your lowest test grade, change it to an I like you never took it. So that's mainly for you to tell your parents when over Christmas break they see you have incompletes, and you can just tell them that Mr. Brown just put in the incompletes to help your grade out. Also because I just want to like de-emphasize grades as much as possible as long as you're learning what you need to learn so that you can do well second semester where it really starts getting tough. And then of course doing well on the AP exam. So I'm gonna go ahead and let y'all get started with that classwork. Again, that will help you with certain problems in choosing the correct view.